So we are on the second part of our entry with radicals. So before we had some simplifying of radicals with expressions involving exponents and variables. What we're going to do now is we're going to take the way we simplify radicals and we're going to do operations with them. So you should have this handout here. I've written in mine, but yours is a blank copy of the operations with radicals handout. So I wrote in mine so we wouldn't waste time, having me write it out and you just kind of watch as I write something down. Now you can just pause it and copy down what I've written for directions, and then I'll refer to it as the video goes on. So I'll have you pause the video and make sure that this whole page is all these fill in the blanks are filled in. So one thing we can do with radicals is we can add them and subtract them, but we can only do that if they're like radicals, like they're both third roots, or they're both fourth roots, or they're both square roots. We can't do it if one's a third root and one's a fifth root because they're different. So like radicals have the same index, right? That's that number that would be up here, okay? And the same radicand, okay? So for example, like the square root of 3 and the square root of 3 we could add together. But the square root of 3 and the square root of 4, the 3 and 4 are different, so those radicands wouldn't be able to combine. Okay, you can kind of think of a radical as a variable. So like you can't combine x and y, but you can combine x and x. So for our first example, we're going to attempt to combine or add to, or subtract here 2 square root 45 minus 2 square root 5. Now if we just look at it right away, I see that they have the same index, but they have different radicands. So I can't immediately add them together. But what I can do is I can change the way they look by simplifying everything first. Okay? So we're going to simplify the square root of 45. And simplifying, if you look back here, means that we find the prime factorization, right? And then we write it out and start taking out groups of whatever the index is, and in this case, the index is empty, so it means it's 2. So my first step is to find the prime factorization of 45. So, using the birthday cake method, if I start with 45, a prime number that goes into 45 is 3. And 45 divided by 3 is 15. And 3 also goes into 15, giving me 5 left. 5 goes into 5, and there's my candle. Right? So, I can rewrite this as 2 times the square root of 3 times 3 times 5. Okay, and now because I've got some groups and I can take out groups of 2 just like the previous entry, I have 3 and 3 here, so I'm going to take out those 3's. And so what I have left, we got 2 times the 3's that I just took out, and then what's left is the square root of 5. Right? And this eventually turns into 2 times 3 is 6 times the square root of 5. So by simplifying the way it looked, what I've done is I've gone from something I cannot combine together because they have different radicands, right? 45 and 5 are different, to something that I can combine. Okay. So now if I have 6 square root 5 minus 2 square root 5, it's kind of like having 6x minus 2x, right? Or 6z minus 2z. These are both the same, so all I do is work with the coefficients. So to combine like radicals, if you look at the directions up here, to combine like radicals, we add the coefficients and keep the same radical. So 6 and negative 2 makes 4, and the square root of 5 is simply the square root of 5. Be careful, you don't want to do 5 minus 5 is 0, right? It's like you have 6 x's, you take 2 of them away, you've got 4 left. Okay. For my next example, right, I have the square root of 12, square root of 3, and square root of 20. So right away, right, I can't combine those because the radicands are different. They're all square roots, so the index is the same, but they have to have the same number inside the square root sign. So, can I change the way it looks by simplifying things first? Okay, and in fact I can. Right? So what we're going to do is we're going to rewrite, okay, these in simplified terms. So we have to find the prime factorization of 12. So if you do the birthday cake method with 12, we can just do it right here. 12. Prime number that goes into 12 is 2. Gives you 6. 2 again. And then finally 3. So I can rewrite the square root of 12 as 2 times 2 times 3. Right? And then I've got this plus 3 square root 3, and then the prime factorization of 20. I might have to start down here more. We've got 5 that goes into it 4 times, then 2, and then 2. So this is 3 times the square root of 2 times 2 times 5. Okay, I know I did that kind of fast. So now, after I find the prime factorization, I want to start pulling out groups of whatever the index is. So if these were third roots, I'd pull out groups of 3. If there's fourth roots, it would be a group of 4. There's no number here, so we assume it's a square root, which means I pull out groups of 2. Here's a group of 2. So I'm going to be pulling out that negative 2. I'm sorry, that 2. And I'll have negative 3. Okay. Times the 2 I'm pulling out. Plus, I have a 3 left over. And I'm adding 3 square root 3. There's nothing I can do with this one, so it just kind of follows along. And then here I'm also pulling out, it looks like a group of 2. And what I have left is the square root of 5. So now I simplify even further. Negative 3 times 2 is negative 6. Square root 3 plus 3. Square root 3 plus 6 square root 5. Okay. Now, I can't add negative 6, 3, and positive 6 here, okay? Because this is square root of 3, this is square root of 3, that's the square root of 5. So I actually can't do anything with this one. It's like x, x, and y, right? I can't combine the x's and the y's, but I can combine these two. So if I have negative 6 square root 3, and I'm adding 3 square root 3, negative 6 plus 3 is negative 3, and I just kind of bring the radical along. So it's negative 3 square root 3 plus 6 square root 5, and that's my final answer. I can't do anything else there. So those are the two examples for adding and subtracting with square roots with any radicals. What you're going to do now is on the left side of this entry, for practice, you're going to simplify these two expressions. Square root of 20 plus the square root of 125. And then number 2 is 2 times the square root of 27 minus 3 square root 48. And when you're done, you can show your teacher, and then you can move on to the next step, which is going to be multiplying radicals.